Behaviorism and classical conditioning. Behaviorism developed in the early 20th century, partly in response to the subjective nature of introspection. Because of the subjective nature of introspection, behaviorists felt it unworthy of scientific study. Behaviors, on the other hand, were observable, measurable, and could be studied objectively. Edward Thorndike and Ivan Pavlov were early proponents of the new approach, and their classic experiments of studying cats in puzzle boxes and salivating dogs laid the groundwork for future psychological research. Following are core beliefs common to behaviorism. First, equipotentiality. This assumption states that learning principles across species are similar. Rats, cats, dogs, and humans all learn in similar ways. Thus, the results of studying behaviors in one can likely be applied to other organisms within the species. Next, SR psychology, or stimulus-response psychology. This principle holds that learning should only be studied by using objective methods that are observable and measurable. Behaviors focus only on the relationship between an observable and measurable stimulus and the resulting observable and measurable response. The next core principle followed by behaviorists is the exclusion of internal cognitive processes. Because they are not observable or measurable and are highly subjective, early behaviorists felt that they had no role in their new scientific process. However, some contemporary behaviors do allow for some cognitive processes when studying behavior. These behaviorists follow an SOR model compared to the SR model, where the O represents the cognitive process that occurs between the stimulus and the response. Along the lines of the SR principle, behaviorists felt that learning can only be said to occur when there is an observable change in behavior. Contemporary theorists, however, do account for cognitive processes when determining whether or not learning has occurred. Behaviorists believe that organisms start off as blank slates and can basically be taught to do almost anything they are biologically equipped to perform. This is summed up in the following quote from John B. Watson, who is often referred to as the father of behaviorism. "Give me a dozen healthy infants, well-formed, and my own specified world to bring them up in, and I'll guarantee to take anyone at random and train him to become any type of specialist I might select. Doctor, lawyer, artist, merchant, chief, and yes, even beggar man and thief, regardless of his talents, penchants, tendencies, abilities, vocations, and race of his ancestors." In line with the previous quote from John B. Watson, behaviorists believe that learning is mostly a result of environmental actions. Given the appropriate environment, an organism will learn accordingly. The final core principle of behaviorism is parsimony. The parsimony principle holds that explanations of behaviors should be concise with as little explanation as necessary to appropriately define the behavior. Now we turn to the classic classical condition experiment from Ivan Pavlov.
Behavioral psychologists have come up with new views, not only of animal behavior, but of human nature as well. And these views all concern a process that we take for granted, learning, because we are all truly born to learn. Ironically, one of the most important figures in the study of learning, Ivan Pavlov, wasn't concerned with the subject at all, at least not at first. Pavlov, a noted Russian scientist, won the Nobel Prize for Physiology and Medicine in 1904. As this original footage shows, Pavlov was initially interested in digestion and the action of the salivary glands. By diverting the saliva of dogs into test tubes, he could precisely measure if and how much they salivated during digestion. When food was presented, the dogs salivated quickly, an inherited salivary reflex. But over repeated testings, a strange thing happened. The dogs salivated before contact with the food. Just the sight of the food was enough to stimulate their drooling. Then, just seeing the food dish, or even hearing the footsteps of Pavlov or his assistants, was enough to trigger this built-in reflex. What was going on to elicit this response? Pavlov decided to find out by systematically varying the stimuli and measuring the dog's reaction. Metronomes, lights, and bells were all used as stimuli, and they all worked as stand-ins for the food. What mattered was not the kind of stimulus that was used, but the fact that it reliably signaled that food was on the way. Pavlov had discovered a fundamental type of learning called classical conditioning. An original stimulus elicits an automatic unlearned response. Both stimulus and response happen naturally. They are unconditioned. Then a second, neutral stimulus that never elicits the unconditioned response by itself is introduced just before the presentation of the original stimulus. If the neutral or signaling stimulus is presented alone, and a response occurs as if the original stimulus were still there, we say that conditioning has taken place. The arbitrary neutral stimulus becomes a conditioned stimulus. The reverse is also true. Pavlov and others studied the extinction over time of such conditioned responses. When the subject learns that the conditioned stimulus no longer signals a desired event, the acquisition process is reversed, as the learned connection is gradually weakened. Pavlov's work, and the work of those who followed him, led to a remarkable conclusion, and that is, any stimulus an organism can perceive is capable of eliciting any reaction the organism is capable of making. This means that virtually any sound, sight, or smell can influence the way our muscles tense or relax, our moods fluctuate, or even the way our attitudes are formed. For instance,
So to recap the classical conditioning model, a neutral stimulus, a bell in the case of the Pavlov experiment, is paired with an unconditioned stimulus resulting in an unconditioned response, salivation. So to recap the classical conditioning model, a neutral stimulus, a bell in the case of the Pavlov experiment, is paired with an unconditioned stimulus resulting in an unconditioned response, salivation. After numerous pairings, the neutral stimulus elicits the unconditioned response. Thus the bell is now a conditioned stimulus, and the resulting salivation by the dogs is now a conditioned response. Following are common phenomena that are common to classical conditioning. Associative bias holds that certain stimuli are more likely paired than others. The text points out that foods are more likely to be a conditioned stimulus with nausea than, say, a bell tone. Contingency is the temporal pairing of the conditioned stimulus with the unconditioned stimulus. Conditioning is most likely to occur when the conditioned stimulus is presented just prior to the presentation of the unconditioned stimulus. Extinction occurs when the conditioned stimulus is repeatedly presented with no presentation of the unconditioned stimulus. Eventually, the conditioned stimulus no longer produces the conditioned response. Spontaneous recovery can occur after a period of extinction. However, the conditioned response is usually weaker and it is extinguished quickly if it is not reinforced. Generalization of a conditioned stimulus can occur if there is a similarity between other neutral stimuli and the conditioned stimulus. The text details the Little Albert study where the initial fear of a white rat led to a more generalized fear of anything that was white and furry. Stimulus discrimination allows for distinction of subtleties in conditioned stimuli. For instance, dogs can be conditioned to not only respond to generic bell tones, but they can be conditioned to respond to a specific bell tone, whether it be high, low, or mid-range. Higher order conditioning is when an unintentional neutral stimulus is conditioned simultaneously with the intended conditioned stimulus. For example, if in the Pavlov experiment a hand clap had occurred at the presentation of the bell and the meat, there would be a possibility that the hand clap would be conditioned as well as the bell. Sensory preconditioning works similarly to higher order conditioning, the difference being that the second order conditioned stimulus is presented prior to the conditioned stimulus, rather than simultaneously. Extinguishing unwanted behaviors can be difficult and unpredictable, because undesirable stimuli are generally avoided, making it less likely that an unpleasant conditioned stimulus would be provided an opportunity to be presented in the absence of the unconditioned stimulus. Another factor is the probability of multiple unknown second-order stimuli. And finally, spontaneous recovery is always a possibility. Counterconditioning replaces one response with another, creating incompatible situations where two conflicting responses cannot occur can countercondition a behavior. Also, systematic desensitization is the slow and gradual exposure to an aversive stimuli. The slow and gradual introduction can reduce and then eliminate the aversion. Following are several ways that behaviorism and classical conditioning can impact the classroom. Practice is important in providing the students opportunities to reinforce positive stimulus-response associations. Therefore, teachers must ensure that students are practicing regularly and are successful in that practice. Teachers must also ensure that the learning environment is positive so that students associate being in the classroom with having a pleasant experience. And as stated earlier, maladaptive, unwanted, conditioned responses are difficult to replace. Exhausting the behavior can work, but it requires a lot of patience from the teacher and the student's peers. Systematic desensitization, or threshold, and incompatibility can also work as detailed earlier. Finally, in order to assess student learning, teachers must be able to identify an observable change in student behavior.